The best way, of course, to get good at anything is just to do a whole lot of problems. Now, if you're super, super good at, whatever you call those things, partial fraction decomposition, don't feel the need to do all of these by hand unless you just need the practice. You know, find a way to do that just so you're not wasting homework time doing something you already know how to do. You really want to be spending your homework time doing stuff that you don't know how to do. But be careful, because on tests you may or may not, be able to do partial fractions on a calculator, so just make sure it's something you can do. Anyway, at this point, what you should do is you should take a look at this, pause the video, and try to solve it on your own. If you have absolutely no idea what I'm talking about, go look at some of the other videos and figure it out. But in any case, pause the video, see how far you can get. Awesome. Okay. So let's pretend that happened. Now what I want to do is I want to take the Laplace of both sides of this equation. Laplace and Laplace. And this is exciting. Okay, so on the left I have 2 times, and I have minus f prime naught, or y, let me go with y's, y prime naught, minus s y naught, plus s squared y, and then 3 negative y naught plus s y. And if you have no idea where that's coming from, you definitely want to go review stuff. Plus y equals 8, 1 over s plus, I think, 2. Yeah. So this is, of course, assuming that you don't have to have your Laplace table memorized, but just to have access to it. Alrighty, and then I'm going to do math. And so that gets you some algebra, and again, this is a DiffyQ video, not an algebra video. So if you made any mistake along the way, lucky you, you have the ability to pause the video and see how much further you need to go. So the next thing we want to do is we want to move stuff to the other side and prepare things for inverse Laplacing. And there you go. And it's a lot more work than that, so don't just make it feel like it just went like super duper fast and you're supposed to do it that fast. You're not supposed to do it that fast. You're supposed to do it on your own for like an hour and then come back and be like, oh, that's what I was supposed to have done. All right, so now I'm going to take the inverse Laplace of both sides, which is pretty straightforward. Now the 2s plus 1, I don't actually have a 2s plus 1, so in order to make that pretty, I'm going to kind of do this off to the side. Right now I have 8/3 times 1 over 2s plus 1. Now what I'm going to do is I'm going to multiply the top and the bottom by a half, and if you've been doing a lot of inverse Laplace transforms, this probably doesn't bother you, and you just skip right over it. So I've got 4/3 times s plus 1/2. So whenever I take the inverse Laplace, I'll have y is equal to something. I'll have y is equal to 4/3 e to the negative 1/2 t, like that. And then, yes, and then I'll have minus 8 e to the minus t, and then 8/3 e to the negative 2t. So not too crazy, it's just a little bit of this you gotta remember how to do, but really it's just muscle memory getting used to it. So let's try the next one. So I'm going to say if you weren't really sure what was going on in the last problem, then you definitely should not try this problem or watch this video until you've actually tried it on your own, or possibly go watch some more videos before you waste this perfectly good, well worked out example and lose the opportunity to discover it for yourself. So if you haven't already, solve this problem on your own, pause the video, see if you can do the Laplace of both sides, do the simplification, all that, because even though it looks easy when you're watching it, the fact of actually having to go through it and be super duper careful because you miss one thing, the whole thing's over, those are really, really good things for you to practice doing. So there's a spot check to see if you've made it this far, and then we keep doing more math. So I'm going to go ahead and I'm going to multiply this by top and bottom by s and s, s. All right, and so I've got, actually this isn't right. That's just silly. I don't even know why I did that. I think because I wanted it to be that way. All right, times s. S. All right, there we go. Much better. So I have 1 plus this thing. Now I've paused, or not paused, but I've slowed down to show you all the steps because I want to make sure that you don't miss something important, like not messing up what I just did. All right. So again, if you've been doing inverse Laplace, this shouldn't bother you too much. But if you haven't, then you may not catch on. But basically what the idea is, this right here, it doesn't factor, but because I'm going to eventually be doing inverse Laplace with it, what I really wish it was s plus 1. So I'm going to complete the square. So I'm going to go, let's see, how shall I do this? I'll go s squared plus 2s plus 1 plus 1. So that's s squared, sorry, that's s plus 1 quantity squared plus 1. Okay, so that means whenever I'm separating it out, I have s, and then I have s plus 1 quantity squared plus 1. On the top here is going to be a, and the top here is going to be bs plus c. Or if I want to be super smart, I can say bs plus 1 plus c. It just kind of depends on how you want to go about it. Okay, nonetheless, whenever I work through it, I will get that y is equal to 1 half times 1 over s minus 7 halves s plus 1 over this s plus 1 squared plus 1 thing, and then minus 5 halves times 1 over s plus 1 squared plus 1. And then it's relatively straightforward to take the inverse Laplace transform. And by relatively straightforward, I mean compared to like other stuff that we could be doing. And on the left, I've got y, 1 half, because 1 over s just goes to 1. And then this first guy here, he's going to be a cosine, because he's got the s on top, but he's going to be shifted. E to the minus t cosine t, because it's the 1. The 1 here is the 1 there. And this guy is going to be in good shape, because he's also shifted, so it's minus 5 halves. E to the minus t, and then sine t. And so look, we just did another diffie q, and it was amazing! What more could you possibly want out of life? Now looking at this problem, this should just remind you of a method of undetermined coefficients, which are never actually any fun. The fun part is whenever we can use Laplace and not have to do it. So again, it's more of an issue if you want to spend your time doing method of undetermined coefficients or finding coefficient thingies for partial fraction decomposition. So again, take the Laplace of both sides, and I'll see you in a sec. Now this is the first step. I just wanted to make sure that you saw that I changed all my x's to t's because I feel more comfortable working in t's in Laplace transforms. So there you go. Now I just wrote all of these out over here on the right kind of independently because it just helps me see it a little bit better. I don't know why. It's just a little intimidating to me, I guess, to do all of that Laplace stuff on its own. So I'm going to write this out, and then I'm going to catch you up here, plus 2y. And so basically what I have is I have that t squared thing, which is basically t to the n, which goes to n plus 1 goes to, oh, sorry, I have this backwards. So if you say t to the, I don't have it backwards, I'm just being weird. If I have t to the n, then I would say that that's n factorial over s n plus 1. But then it's also, whatever you call it, shifted. So instead of s, it'd have to be s minus 3, which is why I kind of wrote it out separately, because it's a little weird to look at. So it's 2 factorial, and then s minus 3 to the 3. And then it's plus 2 times, same thing, 1 factorial over s minus 3 squared. And then the last one is just 1 over s minus 3 from there. So then I've got this lovely thing, and I really don't want to have to write all this out again, so I'm just going to divide the whole thing by s minus 2 times s minus 1, but then I need to multiply the whole top by s minus 3 cubed, so I have an s minus 3 cubed on the bottom, and so I end up with kind of a goofy little thing that I'm then going to partial fraction out, and I'm not going to make you watch me do all of that. And once I do partial fraction decomposition, I get all of that. Now I can inverse Laplace both sides, and I don't know why I'm so obsessive about getting the inverse Laplace. Always seems to have to be blue. Inverse Laplace, all of these guys, and it's actually relatively straightforward again. We've got y is equal to 2, e to the 2t, and I can put these into x's if I want, it's really not a big deal. E to the t, just like that. Good. All right. And let's see, then I've got minus 1/4 e to the 3t. Now this is the square term, so it's supposed to have a 1 on top, so I'll just pull the 1 out, and so then I've got t, and it's shifted, e to the 3t. And then this guy I wish had a 2 factorial on top, so I'm going to divide 1/2 out front. So I've got plus 1/2 t squared, that's not a 2, t squared e to the 3t. And then it's perfect, and it's beautiful, and it's amazing, and I didn't have to do any method of undetermined coefficients. I just had to do a whole lot of algebra, which is basically all that method of undetermined coefficients is anyway, but you know, I did it with Laplace, and that's going to be impressive to somebody at some point. Yay!